Hey, welcome back. Today we're looking at 4.2. We're continuing this idea of real zeros. So we're finally getting into finding the actual zeros. So what we're going to do here is we're going to determine the max amount of zeros. We're going to identify possible zeros like we did last time. You can graph. Step 3 is optional using Desmos. It's actually cheating. If you plug it into the graph and you click on each of the points listed there, it tells you all the zeros. So we're not going to actually have to do work if we do it that way. So step 4 is important. We're going to use Factor Theorem to test the zeros. All right. So step 1 here, it's asking us find the zeros of x cubed plus 8x squared plus 11x minus 20. So step 1, we're looking at the maximum amount of zeros, right? So that's the highest degree. So the max amount of zeros is 3, right? So the most different zeros we're going to have to find is 3. Step 2, if we go back here to check, identify possible zeros. Okay, so remember to do that, we're going to find all the factors of the last and the first. So the last one is 20. So let's write all the factors of 20. So we have positive, negative 1, 2, 4, 5, 10, 20. Now the first part is actually pretty nice because our first term is 1. All right, so if we do all the combinations of the top divided by 1, then this is actually all the different possible zeros. Right? There's no sense in dividing by 1 because it's all going to come out to the same thing. So if we were to divide the last by the first, we'd have the same list as our last. Okay, so that's step 2. Step 3, we can graph if you guys want to graph. So let me kind of write this down so I can type it into Desmos pretty nicely. X cubed plus 8x squared plus 11x minus 20. Okay, and they're telling you to do this because it's helpful and you're going to eventually have to do the work anyway, but let's take a look at what happens if we plug it into Desmos. Okay, so we're going to do x to the third plus 8x squared plus 11x minus 20. Okay. And so here our graph is. And the beauty of Desmos is you can zoom it in or zoom it out, but we can go ahead right here and click on those points and find all the zeros, -5, -4, and 1. All right, so it's actually kind of cheating. But what we're going to do here is we're going to use that information. So notice that these zeros are all part of the list that we had in the beginning, right? -1, 4, and... -4, -5, and 1. All right, so let's use one of them to simplify this a little bit, because we could do all 3 of them and that would be kind of cheating. But let's just use the 1 then. Okay, so we're going to use the Factor Theorem. So step 3, we graphed it. But let's use the Factor Theorem. So what we do is we'd say, okay, f of 1. And then we do our thing. And we just check that it was equal to 0. So that's going to be 1 plus 8 plus 11 minus 20. 1 plus 8, 9, plus 11, 20. 20 minus 20 is 0. Okay, you can do that for each of the different ones, right? So then we have -4 and f of -5. And those should both also come out to 0. Okay, so pretty easy, I think. Pretty straightforward. Let's try another one. This time it's a little bit longer. It's got more zeros possibly, right? So this is step 1. possible zeros leading term is 4. So possible zeros, we could have 4 of them. Okay, step 2. Should probably say maximum possible zeros. Okay, step 2, we're gonna take our first and our last. So last term, our last term is 4, so that's gonna be positive -1, positive -2, positive -4, and then the first term is also 4, so it has the same factors. Okay, what we're gonna do is we're gonna do all the combinations of the last divided by the first. So let's start off with the first term. So we have positive and negative. 1 divided by 1 is 1. 1 divided by 2 is a half. And then 1 divided by 4 is a fourth. Okay, then we'll move to the next one. 2 divided by 1 is 2. 2 divided by 2 is 1, but we already have it here, so we're not going to rewrite it. And then 2 divided by 4 is 1/2. Again, it's still there. It's there already, so we don't have to put another one. Okay, and then the last one, positive -4 divided by 1 is 4. 4 divided by 2 is 2, but we already have it listed. And then 4 divided by 4 is 1. We already have it listed. So of these, we're going to go ahead and graph and check. All right, so we're going to go back to Desmos. This time, let me write it down again. 4x4, 15x cubed, 8x squared, 15x, and 4. X to the 4th minus 15x cubed minus 8x squared plus 15x plus 4. Okay, and then we can go back here, zoom in or out if you need to, and then check your zeros. So we have one at -1, we have one at 1, we have one at 4, and -0.025 is -1/4. So what we do at this point, again, is we're going to plug them in and make sure they equal to 0. Let's do 1/4, I guess, because that's going to be the one that's going to be hardest for you. You guys can check the rest. So -1/4, it says is a 0. All right, so let's do 4, -1/4, -1/4 cubed, -1/4 squared, -1/4, and 4. Okay, so -1/4 to the 4th, yuck. That's going to be 4 times 4 times 4. What is 4 to the 4th? 16, that's 265. 4 to the 4th, 256. So 4 times 1/456 is going to be 256. Yikes. This time we're going to do -1/4 to the 3rd. That's going to be -15 times -1/64, which is going to be positive 1/64. And then this one, -1/4 squared is 1/16. And then we have the -8, so 8/16. Then we have 15 times -1/4 is -15/4 plus 4. If you guys have a graphing calculator, a scientific calculator, you guys could have done that all at one time and make your job a lot easier. But let's kind of simplify this a little bit. Oops, I forgot the 15 here. 15. Okay. Yeah. All right, so let's see. Let's simplify this. 4 over 256, they're both divisible by 4. So if I simplify that, that's 1/64 plus 15/64. Let's do common denominators here because that's probably going to help us out. So let's do it all 64ths then. So I'm going to multiply with 4 and 4. So that's 32/64. And then I'm going to have to multiply this by 16. 15 times 16 is... 15 times 16 is 240. 64ths. And then we'd have to do 64 over 64 for that 4. So 4 times 64 is 256 over 64. Ugh. Okay, so let's try to add this. 1 plus 15 is 16. Minus 32 is negative 16. Minus 240 is negative 256. Plus 256 is 0 over 64. Awesome. It's 0. And we said that if we factor it, then we should get a 0. I mean, if we substitute it, we should end up with a 0 if it is in fact a factor. Keep in mind, you could do 0.025. It'll come out with like weird decimals. But if you're doing it in your calculator, you can just plug it in like it is. It'd skip us all this headache of doing that middle part, and it would just tell us that our answer is 0. So, yeah, you'd be doing that for the other 3 zeros as well. Okay, so it's a little bit tedious work, but it is helpful. It tells us where our zeros are from the graph, and it verifies that our zeros are actual zeros. And it's a little bit easier than the way that I originally did this without the graphing, and then that would be guess and check to find a 0 using the factor theorem and then doing long division. So this kind of does save